Hello everyone, in this part I want to give some important notions and notations and definitions about vectors. In the beginning of Calculus 1, we had functions of one variable, and then we had functions of two variables and three variables, and we had their limits, we studied continuity of them, we had their derivatives and integrals. And finally we will have, from this point, we will have the vector fields. The vector fields generate vectors. Okay. In order to understand the concept of vector fields, we first must focus on the vectors. The term vector is used to indicate a quantity. What kind of quantity? Maybe force, velocity, or displacement that has both magnitude and direction. These two are very important, magnitude and direction. Okay. If a line segment has two properties, has two things, then it is a vector. What is the magnitude? A vector is often represented by an arrow or a directed line segment. The length of the arrow represents the magnitude of the vector. Let's say V has the components A1, A2 and A3, as you see. So the magnitude of the vector V is given by this formula. Okay. If we call this as norm, okay, or the magnitude. If the magnitude is 1, if the magnitude of a vector is 1, then it's called a unit vector. What about the magnitude if you have PQ? X1, Y1 and Z1 represents the point Q. X2, Y2 and Z2 represents the point P. So the magnitude or length of this vector is also given by this formula. Okay. You are familiar with the vector addition. If you have two vectors V and W, then the sum of these two vectors is the vector is also the vector from the initial point of V. Okay, the sum of V and W, is the initial point of V to the terminal point of W when the vectors are positioned. So the initial point W is the terminal point of V. Scalar multiplication of vectors. If C is a scalar and V is a vector, then the scalar multiple CV is the vector whose length C times the length of V. Okay, and whose direction, of course, is the same. Direction does not change when you multiply a vector by a constant. Dot product and cross product, these are very important. Let's say you have two vectors A and B. Then the dot product of, let's say the components of A and B are given like that, okay? Then the dot product of AB is equal to the multiplication of first components plus multiplication of second components plus multiplication of third components. Let's look at the example. So this is equal to minus 1 times first component of this vector 6 plus second component of first vector times second component of second vector plus last component of first vector times last component of second vector. If you add them up, then you have minus 6 plus 14 minus 2. Then what do you have? 6. Okay. So finally you have a number. You have a numerical value. You don't have a vector, okay, anymore. What about the second one? First component of these two vectors, the multiplication of them is, this is equal to 1 times 2 plus, very sorry, see, it's a big mistake. Let me write these two vectors properly. 1, 2, minus 2 are the components of the first vector. 0, 2, minus 1 are the components of the second vector. Okay, since you don't have I, the coefficient of I must be 0. Then you have 1 times 0, I don't write this, plus 2 times 2, 4, plus minus 3 times minus 1. Minus 3, that is 7. Okay. So let's continue. Properties of dot product. We have many properties of dot products. As you see, you can change the order of the vectors when you have dot product. If you have a constant, then you can put this constant in the parentheses. Okay, and dot product of a vector by itself gives the norm of the square of norm, or the square of the magnitude. Okay, so it's possible to write u dot product v plus w as uv plus uw, and finally the dot product of a vector by zero vector is always a zero vector. It must be a vector. Okay, now we have a theorem. If theta is the angle between the vectors u and v, it must be v. Okay, u and v, then cosine theta is equal to u dot product v divided by norms divided by the product of the norms of u and v. So we have a question now. We have a question. Find the angle between these two vectors. Okay, so I will directly use this theorem. So to do this, I need to find the norm of u. Okay, the norm of u, that is 2 square 4 plus 2 square 4 plus minus 1 square 1, that is 3. Norm of v, that is magnitude of v, is equal to, v is here, 5 square 25 plus minus 3 square 9, and finally plus 2 square is 4. Then this is square root of 38. Okay, and dot product of u and v, let's compute this. Dot product of u and v is 2. So cosine theta becomes, I directly use this formula, u dot v is 2 divided by 3 square root of 38. Okay, then it means theta is equal to arc cosine of this number. Okay, so if you compute, you will have approximately 1.46 or approximately 84 degree. Okay, this is the angle theta. The second example show that this vector is the perpendicular to this vector. So how do we find this? I want to remind you that two vectors u and v are perpendicular or orthogonal. Orthogonal if and only if u dot product v is 0. Okay, if the dot product of two vectors is 0, then it means these two vectors are orthogonal to each other or perpendicular to each other. So let's solve the example here. Okay, so let me first write the first vector, 2 minus 1 dot product 5 minus 4 and plus 2. Okay, let's see the dot product of these two vectors. The dot product, 2 times 5, 10, 2 times minus 4 is minus 8, minus 1 times 2 is minus 2, and it is 0. Since the dot product of these two vectors are 0, it means they are perpendicular to each other, so we showed. Okay, and the cross product of two vectors a and b are given by these matrices, or if you do not remember the matrix, then you have this form. Okay, a cross b is equal to the vector. This is the first component of the vector, this is the second component of the vector. So let's look at this example. A and b are given here. Okay, and the cross product, in the first row we write ijk, in the second row we write 1 3 4, which is the first vector a. In the last row we write the second vector. Then using this formula or computing this matrix, you easily find the cross product of the vector. I want to mention about this theorem here. The vector a cross b is orthogonal to the a and b. Okay, let's see how it happens. Let's say this is the vector a. This is the vector a, okay, and this is the vector b, and this is theta between the vector a and b, and this line is a cross b, and as you see, this theorem says that a cross b, which is the cross product of ab, is orthogonal to both a and b. Okay, and we have a corollary. Two non-zero vectors a and b are parallel to each other if and only if the cross product is 0. And we have some nice properties of cross product. Okay, if you change, for instance, for the first one, if you change the order of cross product, then you put a minus here. Okay, what about, and finally I want to mention about parametric equations of lines. The line in our cube or in three-dimensional space that passes through the point x0, y0, z0 and is parallel to the non-zero vector ABC has this parametric representation. Each value of parameter t gives the position vector r. So r is called position vector. Now we have an example. Find the vector equations equation, okay, we don't have s here, and parametric equation for the line through the point 5, 1, 3 and is parallel to the vector I plus 4j minus 2k. Okay, so I want to use this formula which is given here. Using this formula we have 5 plus t. Why do I have this? Since the coefficient of I is 1 and you have 5 here, 5 plus 1 times t, this is 5 plus t. Y is equal to 1 plus see, you have 4 here, 4t, okay, and z is equal to 3 minus 2t, okay. Or if you want to write the position vector, then you have 5 plus t, the first component, the second component and the third component of the position vector. Of course you have t here. For each value of t you have a vector. This is why it is called position vector. Okay, so I think it's enough for the time being. I will focus on the line integrals.